Hello, guys. Are you guys still doing good? Ano yun? All right. So don't you guys worry. The other modules, let's see, module 5 and 6 are already self-explanatory, or if not, it's have or browsing the internet is already enough. Unlike for the module 4, so we really have to discuss this one since this one is quite complicated, especially if you're new to binary systems or number systems. All right then, so let us now continue our discussion. So are you guys ready now? Hello? May we continue now our discussion? All right, so how to derive two's complement, okay? So in here, we have to represent this -9, okay, into a binary with 8 bits, okay? Or it is 1. All right, so the first thing that you need to do is write the positive 9 in 8-bit binary. Okay, so you have to represent the positive 8-bit first, wherein, as you guys can see right here, it's the 8 plus 1 is equal to 9. All right? And then the next thing that you need to do is complement each bit and then add 1. So once you complement each bit, again, your 0 will become 1, your 1 will become 0. So just change that 1 into something like this. So 1 became 0, 0 became 1, 0 became 1, 1 became 0, and then all of your zeros became 1. All right, so that is the second step. And then add 1. Okay, just add 1. So 0 plus 1 is 1. And then just copy everything. Okay, since we have already added 1 in here. So in here, this is now actually your sign binary of -9, okay, which is 1, 1, 1, 1, 0, 1, 1, 1. All right, which is the same with this one. So 1, 1, 1, 1, 0, 1, 1, 1. So this is the representation of -9 into binary with 8 bits. Were you guys able to follow? All right. So don't you guys worry, this one is super simple. Okay, how about we answer, do we have the solution? All right, so 9. So let's answer letter A. Okay, so the first step that you need to do, is represent this 1 to its positive form. So positive 25 by 8-bit. So we have 16 plus 8. So it's 0, 0, 0, 1, 1, 0, 0, 1. All right. So this is 8 plus 9, 8 plus 1 is equal to 9, plus 16 is 25. And then apply 2's complement. Okay, so your 0 will become 1, and then your 1 will become 0. So 1, 1, 1, 0, 0, 1, 1, 0. And then the third step is plus 1, right here. Okay, so 1 plus 1 is 1. And then the rest are just numbers wherein you need to bring it down. There you go. Okay. And yeah, so this is now the representation of -25. 1, 1, 1, 0, 0, 1, 1, 1. All right. So are we clear so far? No. Are we clear with this example? Okay. So you only have 3 steps to represent this negative 25 into binary number. Okay, so we have the positive form, and then the 2's complement, and then just add 1. Okay, and then you will have this one. All right, so that's it for the sign number operation. So I will leave this one to you guys. So this one is super simple. Just transform this one into a binary number, and then just add everything. Same this one, transform this one into binary. And then for the negative 13, so we have to apply 2's complement, right? So get the positive form, and then 2's complement, and then plus 1. And then you will get this one. And then that's the time that you can now proceed with subtraction. Okay, subtraction of binary. All right, and another exercise. So just do this one as your practice exercises, right? And then here are the character representation wherein just like what I mentioned in part 1. So the last one is the Ascii code, or the American Standard Code for Information Interchange, wherein 7 bits is a total of 128 characters. Okay, and then those are containing non-printing and printing characters. So when I say non-printing, those are the characters that we cannot print since it has a combination of a, let's say, letters or symbols or numbers. And then when we say printing characters, those are the things that being represented by letters, by digits, or by punctuation. Okay. And here's the ASCII code. So in here you have the decimal, 0 to 31, hexadecimal, so 0 to 1F, octal, which is 0 to 37, the character, and then the meaning of those characters, and to yeah, up to 127, right? And then their equivalent results when it comes to hexadecimal, octal, HTML, and then character. So as you guys can see, we have here a character of, let's say, 4, okay? And then the decimal of this one is 52. Okay, each one of them has another equivalence, wherein in hexadecimal, 4 is 34. In octal, it's 064. In HTML, it's ampersand, number sign, and then 52. Okay, so those are the codes, okay, under our keywords or any actions that we do with our computer. Okay, so those are just exercises where yeah, you can do that one. It's quite fun. And we have here some of the meanings of the binary storage and registers, wherein we have the register transfer operation, digital logic circuits, and here's the sample transfer of information with registers, wherein of course initially you're only pressing J, O, H, N, and then it will be passed through our arithmetic or ELU, arithmetic logic unit, or the control. And then it is now going to start forming it cell by cell. Okay, so it could be by bit, so depending on the size of that data. So I guess in here could be represented by 8 cells. So 8 cells is already enough for letter G, 8 cells for O, 8 cells for H, and then 8 cells for N. So that is why we have 8 cells in here. Okay, and yeah, so this will serve as our input, and then it will be processed, and then each one of them is being represented by a binary number, and then yeah, so that's what is being recorded to our memory register. So it is not the N, it is not the H, it is not the O, it is not the J. So all of the data that is being processed to our processor will become a zeros and ones only. So it's just being represented by a number. All right, and then here's another operation when it comes to addition. Okay, operand 1, operand 2, and then what is the operation that you're going to use, and then the result, etc., etc. So yeah, there you go. So that's it for the module 4. So before we end our meeting, do you guys have a question so far? Okay, so let me just call you guys one by one if you guys are still there. Mr. Jeremiah.
Present, sir.
Are you still okay?
Yes, sir.
Kaya pa?
Sakto lang, sir.
So you guys now only have 2 days, 3 days. Okay? Module 3 and 4. Miss Jello?
Present, sir. Na?
So, UK? So, how many
Yes,
percent?
sir.
How many percent you were able to understand our topic for today? Lahat ng topic
Maybe 90%, sir.
Wow. Sweet. How about Mabanag? Miss Mabanag?
Present, sir.
Okay. Miss Diana? Mamaya ka na, Mr. Kit. Wala ka pa eh. Okay, so, alright. So, I guess, madami ka naintindihan, Miss Mabanag. And same with Miss Tulay. Okay, so, present. So, inunahan niya na ako. Mr. Hector, are you there?
Present, sir.
So, how was our discussion for today?
Mga 75 to 80% lang naintindihan ko, sir.
Alright, so it's understandable. So just move back on the part wherein you wasn't able to understand fully. How about Kit?
Sir?
Balikan mo na lang yung mga part na hindi mo masyado naintindihan. Okay, since recorded naman
Yes,
to.
sir. Apo.
Okay, so si Kit, sumagot na to kanina. Okay, how about you, Miss Esguera? Ay, Mr. Esguera. I guess he's speaking, but I cannot hear anything. Press answer. Okay, Miss Balondo.
Sir?
Okay, so how are you?
Sakto lang. Okay lang naman, sir.
Okay. So, all right then. How about Miss Joanna Marie?
Present, sir.
Right, lasa. Energy na energy. Anyway, so this is my only favor. If you guys have encountered a problem or if you're confused about with our discussion, so feel free to ask me anytime. Okay, I don't bite people. Okay, I'm actually blessed or grateful to help you guys. Since you guys are really lending your effort to learn anything or learn a certain topic. All right, so this might be our last meeting. Okay, so the remaining modules, let's see, module 5 and module 6, we're not going to meet with those modules anymore since they are more on definition. Okay, like you can search for the meaning of this one and that one for more explanation. So I'll leave the module 5 and 6 as your self-study modules. All right. So are we clear with that one, guys? All right. And also prepare for this coming Thursday for your quiz on module 3 and module 4. All right. So yeah, I guess that's it. And do not forget to answer our case studies, right? Our discussions. Okay, so if you guys do not have a question anymore, then you guys may now go. And Miss Tulay, so for now, since you told me that you wasn't able to understand the last topic, So would you like me to repeat it for you? I guess we still have 30 minutes. And to the others who doesn't have a question anymore, so you guys may now go if there is still something that you will be doing. Goodbye, Mr. Esguera. Goodbye. Goodbye, goodbye. All right, goodbye, goodbye. How about you, Miss Tulay? Miss Tulay, are you still there? All right. So let me just share my screen again. Where is that part that you didn't understand? This one? Sign binary numbers. All right. So from here, you only have 3 steps. Okay. Or the first thing that you need to know when it comes to a sign binary number is, yes, representing a positive number is no problem. Okay. But how about if it's negative? Okay. We don't have negative sign on binary numbers. So that is why our computer or the mathematicians who have created this logic create this sign binary numbers to represent a negative decimal to our computers. Like for example, okay, so we want to have a representation of -9, okay. So the first thing that you need to do is write that 1 into a positive 8-bit binary. So I guess no problem with this one, right? So just present it as a binary. So we have 1001. Okay, and then the rest are 0 since we only need 9. So 8 plus 1 is positive 9. So are we clear with this one? Ms. Tulay? Hello? Are you still there? All right. And then the second step that you need to do is apply complement. Okay. So when you say complement or 2's complement, so the 0 will become 1 and then the 1 will become 0. Okay. So 1 will become 0, 0 will become 1, 0 will become 1, 1 will become 0, and then all of those zeros will become 1. So are we clear with this one? Hello, Ms. Tulay? Are we clear with 2's complement? Okay. So gets mo na? And then just add 1, and then you will get this one. Okay, so this is now the sign binary number of -9. Okay, so yeah, that's it. And then the one that we had before is the letter A. So I've represented it into positive. Yeah, this one. So I've represented it into a positive, okay, positive binary number. Okay, so 1 plus 8 is 9, plus 16 is 25, which is this one. Tama? And then from here, just apply 2's complement. So 1 will become 0, 0 will become 1. So 1 became 0, 0 became 1, okay, etc., etc. Just follow that one. And then the last one is add 1 or plus 1. Okay, so 0 plus 1 is 1. 1 or bring down everything since wala naman ng mga numbers sa baba. Okay, and then there you go. So this is the representation of sign binary number of -25. So clear? Okay. All right then. So thank you so much then for coming. And yeah, so good luck with our quiz this coming Thursday. Okay, so goodbye. Thank you too.